Hi, my name is Robbie Tulip, and for my Seng 475 project, I chose to make an entity component system, or ECS, and use it to make a simple game of Pong. Very briefly, an ECS is an architectural design pattern used to make code more cache-friendly by default. As the name suggests, an ECS has three main parts: entities, components, and systems. Components are simply instances of data where components of the same type are guaranteed to be stored contiguously in memory. Entities are a simple identifier which groups a set of components together to form an object of sorts. And systems are simple pieces of behavior which act on entities so long as they have the right set of components. Before getting into too much detail about how everything works, let's have a look at the game in action. I've already installed the demo by following the instructions in the README. This command here will run the demo and start the game. After starting the game, I can control the red paddle with the W and S keys, and the blue paddle with the I and K keys. You can see two counters at the bottom of the screen, one for the number of frames per second, and the other for the number of entities currently in the game world. As it says on screen, I can press the spacebar to make a ball, and it goes off in a random direction and bounces around the world sort of how you'd expect. When it collides with one side or another, the ball is destroyed, the number of entities is decreased, and the player's score up at the top of the screen increases. You're allowed to have up to 100 balls on screen at any given time. Here I'll just show a few. By closing the GUI, the demo ends, and with that out of the way, I'll give a brief overview of how my ECS is used and some of its interesting features. At the start of the program, I create all the system objects which are required for the game, and I also create a world object, which is simply the manager for the entity component system. At this point, I have to specify which components are allowed to be used within the scope of this world. Next, I build some initial entities into the world, and these entities comprise of different components. Here, for instance, this entity has a position component, a velocity component, a rectangle shape component, a color component, and a side component. This entity in particular is everything that is what describes the left paddle in the game, seen in red. So after I build all of the initial entities into the world, the next thing I do is I add the systems into the world. This is done by providing a pointer to the system, an identifier, and a list of dependencies. After you've added all of your systems and their dependencies, you can use the world dispatch function to execute these systems in order with taking these dependencies into account. The ECS performs analysis on these system dependencies in order to automatically parallelize systems when possible. This is done by making a graph of dependencies and performing a BFS topological sort. Here's what this sorted graph looks like for my game of Pong and its systems. We can see that systems are run from top to bottom, and that most of these systems have to be run sequentially. However, there are some which are on the same level, and thus these can be run safely in parallel. The ECS assumes that the programmer has correctly identified all of the dependencies for a given system. In particular, it's essential that systems which operate on the same components have a dependency specified, either directly or indirectly through another system. Under this precondition, systems can be executed in parallel without requiring any locking mechanisms around the data because mutual exclusion is guaranteed through these dependencies. Tracking the dependencies may seem tricky as a programmer, but because systems only operate on a limited number of components, it's easy to tell which systems have data dependencies. Using the movement system as an example, we can see I define a class, movement system, which inherits from the system class, which in turn requires the components which are going to be operated on to be specified. In this case, position and velocity. The system class has a virtual function, run, which is called once for every entity which has the correct components. In this case, the run function of the movement system applies the entity's velocity to its position. By explicitly stating which components are being operated on, it's easy for a programmer to find other systems which use the same components, and then make sure that there is some dependency defined when you're adding systems into the world. This covers most of the features provided by my ECS. There are some interesting features and challenges that I don't have time to cover in this video, such as adding or removing entities from within systems. But everything's been documented and can be read either in an editor or in your browser from the code from the HTML generated by Doxygen. Thank you very much for watching my video, and I hope you enjoyed.